Look up at the night sky for a moment. It looks peaceful, doesn't it? A silent, sparkling tapestry of distant suns and quiet galaxies, all seemingly locked in a timeless dance. We've been taught that the universe is expanding, that galaxies are flying away from each other, and that the vastness of space is growing more distant every single second. But deep in the direction of the Centaurus and Hydra constellations, there is something that defies the rules. Something so massive, so powerful, and so mysterious that it is currently pulling our entire galaxy, along with hundreds of thousands of others, toward it at a staggering speed of 14 million miles per hour. It's not a black hole, at least not a single one. It's not a supernova. It is an invisible cosmic gravitational anomaly known as the Great Attractor. And the most terrifying part? We can't even see what it is because it's hiding right behind the thickest, dustiest part of our own Milky Way. We are racing toward a destination we don't understand, chased by a force we can't visualize, across a distance that boggles the human mind. Today, we are taking a journey into the heart of the zone of avoidance to face the most terrifying place in the known universe. A place where gravity wins every battle, and where the very fabric of space seems to be folding in on itself. To truly grasp the scale of the Great Attractor, we first need to talk about how we even found it. For a long time, astronomers thought the universe was a pretty uniform place. According to the Big Bang Theory and the expansion of the universe, everything should be moving away from everything else in a predictable way. But in the late 1970s and 80s, scientists realized that the math didn't add up. When they measured how the Milky Way and our neighboring galaxies were moving, they noticed a strange deviation. We weren't just drifting with the cosmic flow. We were being pulled. It was like noticing that all the boats in a massive ocean were suddenly drifting toward a single, invisible whirlpool. This wasn't just a local phenomenon. This was an entire sector of the universe, spanning hundreds of millions of light years, all heading toward a specific point in the dark. This realization sent shockwaves through the scientific community. If gravity is the architect of the universe, then whatever was causing this pull had to be unimaginably massive. We are talking about the mass of tens of thousands of Milky Ways. But when astronomers pointed their best telescopes toward the source of this gravity, they hit a wall. In the world of astronomy, this wall is called the zone of avoidance. It sounds like something out of a science fiction movie, but it's a very real technical challenge. Our own galaxy, the Milky Way, is shaped like a disk, and we happen to be sitting right inside that disk. When we try to look out toward the Great Attractor, we are forced to look through the plane of our own galaxy. This region is choked with hundreds of billions of stars, thick clouds of interstellar dust, and glowing gas. It's like trying to see a lighthouse through a blizzard while standing in a room full of smoke. This dust absorbs and scatters visible light, making the Great Attractor effectively invisible to traditional telescopes. But as technology advanced, we found ways to peer through the veil. We started using X-ray and radio astronomy. Unlike visible light, radio waves and X-rays can slide through those thick dust clouds like they aren't even there. And what we found on the other side was even more overwhelming than we imagined. We didn't just find one big object. We found a cosmic metropolis. The Great Attractor is located in the vicinity of the Norma Cluster, a massive grouping of galaxies. But even the Norma Cluster wasn't enough to explain the gravity we were feeling. It turns out the Great Attractor is just the center of an even larger structure, a supercluster called Laniakea. Laniakea is a Hawaiian word meaning immense heaven, and it fits. It is a cosmic web of 500 million light-years across, containing over 100,000 galaxies. Our Milky Way is just a tiny, insignificant speck on the outer fringes of one of its many branches. Now, let's talk about the physics of this attraction. In space, gravity is a game of mass. The more mass you have, the more you warp the space-time around you. Think of the universe as a giant trampoline. If you place a bowling ball in the center, it creates a dip. If you place marbles around the edge, they roll toward the center. The Great Attractor is like a massive lead weight in the middle of that trampoline, and we are the marbles. But here's the terrifying twist. While we are rolling toward the Great Attractor, the Great Attractor itself is being pulled towards something even bigger. Deep behind it lies the Shapley Supercluster, the largest concentration of matter in our local universe. It contains more than 8,000 galaxies and has more mass than anything else we have ever detected. We are caught in a cosmic chain reaction of gravity, being dragged across the void toward an uncertain future. Why is this terrifying? Well, for one, It challenges our understanding of the ultimate fate of the universe. We used to think that the universe would simply expand forever until every galaxy was too far away to see any others. This is known as the Big Freeze. But structures like the Great Attractor suggest a different kind of ending, one where gravity tries to pull everything back together into a great crunch. However, there's an even weirder player in this game, dark energy. Dark energy is the mysterious force that is making the universe expand faster and faster. Right now, it's a tug of war. Gravity is trying to pull us into the Great Attractor, but dark energy is trying to push us away. According to current models, the Great Attractor is actually losing the fight. The expansion of the universe is so fast that we will likely never actually reach the Great Attractor. We are essentially on a treadmill, running at 14 million miles per hour toward a destination that is moving away from us even faster. We are forever chasing a ghost. But let's imagine for a second that gravity wins. What happens if we actually get there? As our galaxy moves closer to the heart of the Great Attractor, the density of galaxies increases. Space becomes a crowded place. In these regions, galaxy collisions are common. Galaxies don't just pass each other, they tear each other apart. Their gravity strips away gas and stars, creating massive tails of cosmic debris. Black holes at the centers of these galaxies merge, releasing energy that can wipe out entire star systems. The heart of the Great Attractor is a graveyard of galaxies, a place where the order of a spiral galaxy is ground down into the chaos of an elliptical one. It is a high-energy environment, filled with intense radiation and gravitational tidal forces that would make life as we know it impossible. Technical enthusiasts often ask about the Great Wall and its relation to this anomaly. The Great Attractor is a node in what we call the large-scale structure of the universe. When we map out galaxies, they aren't scattered randomly. They form filaments, like a spider web or the neural network of a giant brain. These filaments are made of tens of thousands of galaxies, and the nodes where these filaments meet are the superclusters. The Great Attractor is one of these nodes. It represents a concentration of dark matter, that invisible substance that makes up about 85% of the matter in the universe. We can't see dark matter, we can't touch it, and it doesn't interact with light. We only know it's there because of its gravity. In many ways, the Great Attractor is a temple of dark matter, a place where the invisible majority of the universe shows its true power. Let's look at the speed again, 14 million miles per hour. That is nearly 4,000 miles every single second. As you have been listening to this, you have traveled tens of thousands of miles through the void toward the Great Attractor. You don't feel it because everything around us is moving at the same speed. It's like being on a perfectly smooth airplane. You can walk around, drink your coffee, and feel totally still, even though you are moving at hundreds of miles per hour. But on a galactic scale, this motion is violent. It's creating a dipole repeller effect, where it looks like we are being pushed from one side and pulled from the other. The empty spaces in the universe, the voids, are actually pushing our galaxy toward the concentrations of mass. We are being squeezed out of the emptiness and into the cosmic cities. The mystery of the zone of avoidance continues to haunt astronomers. Even with our best infrared and X-ray tools, there are still parts of that region we can't see. There could be things hiding there that dwarf the Great Attractor. There could be massive black holes, weird energy signatures, or types of matter we haven't even theorized yet. Every time we build a better telescope, the map of the local universe gets a little bit scarier. We recently discovered the South Pole Wall, an even larger structure that sits right on the edge of our detection capabilities. It seems that the deeper we look into the dark, the more we find that the universe is far from empty and far from peaceful. It is a violent, crowded place where massive structures are constantly fighting for dominance. For some, the Great Attractor is a source of cosmic nihilism. It reminds us how small we are. Our sun is one of 400 billion stars in the Milky Way. Our galaxy is one of hundreds of billions in the observable universe. And yet, this entire massive structure is being pushed and pulled like a leaf in a storm by invisible forces. It reveals that we are not the masters of our own destiny. We are passengers on an ancient celestial journey that began billions of years before we existed and will continue billions of years after we are gone. The Great Attractor is the ultimate reminder that in the face of the universe, our concerns, our wars, and our triumphs are smaller than grains of sand. But for others, especially those with a passion for space and physics, the Great Attractor is the ultimate puzzle. It represents the frontier of our knowledge. If we can understand why matter clumps together in this way, we can understand the origin of everything. We can understand why the Big Bang didn't just create a smooth, boring cloud of gas, but instead created this complex, beautiful, and terrifying web of light and shadow. The Great Attractor is the key to the Laniakea supercluster, and understanding Laniakea is the key to understanding the architecture of reality itself. Let's dive into the Vela supercluster, which was recently discovered and might be an even more powerful player than the Great Attractor. For years, astronomers were puzzled because the Great Attractor didn't seem quite strong enough to explain the speed of our motion. In 2016, a team of researchers announced they had found a massive structure behind the Great Attractor, hidden by the same dust clouds. The Vela supercluster. It is even further away, but it is so massive that it contributes significantly to the gravitational pull we experience. It's like realizing that the whirlpool you were worried about is actually just a small swirl on the edge of a massive hurricane. The scale of the universe just keeps expanding as our eyes get better at seeing the invisible. How do we even map something we can't see? We use something called peculiar velocity. In space, you have two types of motion. There is the Hubble flow, which is the movement caused by the expansion of the universe. This is the motion that pushes everything apart. Then there is peculiar velocity, which is the motion caused by the local gravity of nearby objects. By calculating how much a galaxy's motion deviates from the Hubble flow, we can figure out where the mass is. It's like watching leaves blow in the wind. Even if the wind is blowing everything in one direction, if you see a bunch of leaves swirling toward a specific spot, you know there's a low-pressure zone or an obstacle there. By mapping the peculiar velocities of thousands of galaxies, we can create a three-dimensional map of the gravity in our universe. This is how the Laniakea supercluster was mapped. It wasn't by taking a picture, but by mapping the flow of the cosmic river. Think about the sheer energy involved in moving a galaxy. A galaxy like the Milky Way weighs about 1.5 trillion times the mass of the Sun. To accelerate that much mass to millions of miles per hour requires a gravitational force that is almost impossible to calculate. This energy is all around us, silent and invisible. It is the same force that keeps your feet on the ground, but scaled up to a level that can move billions of stars as if they were nothing. This is why gravity is the most terrifying force in the universe. It doesn't need to explode like a star or burn like a sun. It just exists, pulling and pulling, never sleeping, never stopping, until everything is brought together. As we look toward the future, the question remains, where does this all end? If dark energy continues to accelerate the expansion of the universe, our local group of galaxies, which includes the Milky Way and Andromeda, will eventually become isolated. The Great Attractor, the Shapley supercluster, and the Vela supercluster will eventually move beyond our cosmic horizon. They will be moving away from us faster than the speed of light, meaning their light and their gravity will never reach us again. We will be left in a lonely bubble of space, surrounded by nothingness. The great cosmic metropolis of Laniakea will vanish from our view, and we will be alone in the dark. In a strange way, that might be even more terrifying than the Great Attractor itself. The idea that everything we see today, all these massive structures and billions of galaxies, is just a temporary feature of a universe that is destined to become empty and cold. But for now, the chase is on. We are still racing toward the center of the web. The Norma Cluster, the Great Attractor, the Shapley supercluster. These are the landmarks of our journey. We are part of a giant cosmic migration, and while we may never reach the destination, the fact that we can even know about it is a testament to human ingenuity. We are a species that lives on a tiny planet, orbiting a middling star, on the edge of a standard galaxy, and yet we have managed to peer through the dust of our own home to map the giants that live in the dark. We have decoded the language of light and gravity to understand our place in the cosmic hierarchy. The Great Attractor also influences our search for extraterrestrial life. If galaxies are constantly being pushed into high-density regions, what does that mean for the stability of solar systems? In the dense core of a supercluster, the night sky would be blindingly bright. Stars would be so close together that their gravity would constantly disrupt planetary orbits. It's possible that our location on the quiet, lonely outskirts of the Milky Way, far from the chaotic heart of the Great Attractor, is exactly why life was able to evolve here. We are in the suburbs of the universe, far from the dangerous, high-traffic downtown areas where cosmic accidents are a daily occurrence. Our isolation might be our greatest protection. Let's take a moment to imagine the view from a planet inside the Norma Cluster, right in the thick of the Great Attractor. The night sky would not be dark. It would be filled with the glowing disks of dozens of nearby galaxies, each one as large as our moon. You would see the spectacular light of millions of blue giant stars and the violent glow of active galactic nuclei. It would be a scene of overwhelming beauty and absolute terror. You would be living in the heart of the most energetic region of the universe, watching the slow-motion collision of worlds on a nightly basis. Compared to that, our quiet sky is a blessing. The Great Attractor also plays a role in the axis of evil, a term used in cosmology to describe a strange alignment in the cosmic microwave background radiation, the heat left over from the Big Bang. Some scientists believe that the gravitational pull of these massive superclusters might be responsible for certain patterns we see in the oldest light in the universe. It suggests that the lumpiness of the universe isn't just random, it's a fundamental part of how reality was structured from the very first nanosecond. The Great Attractor isn't just a place, it's a symptom of the universe's original design. Every year, our simulations get more accurate. We can now run digital universes on supercomputers, inputting the laws of physics and watching how galaxies form and cluster. These simulations show that the Great Attractor is an inevitable result of gravity working over billions of years. Any universe with matter will eventually develop these massive attractors. They are the drainage basins of the cosmos, where the matter falls like water down a hill. Our Milky Way just happens to be in a very steep part of that hill. What does the future hold for our study of this anomaly? New missions like the James Webb Space Telescope and future radio arrays will continue to strip away the layers of the zone of avoidance. We are getting closer to seeing the Great Attractor in high definition. We will eventually know once and for all if it's a massive cluster, a primordial black hole of unimaginable size, or something completely new. We are also learning more about the dipole repeller, the empty region of space that seems to be pushing us from the opposite direction. It turns out that being pushed by nothing is just as important as being pulled by something. The universe is a balance of voids and clusters, emptiness and density. As we reach the limits of our journey today, it's important to remember that the universe is not a static place. It is a living, evolving system. The Great Attractor is just one chapter in a story that has been unfolding for 13.8 billion years. We are living in a special time when we can see these structures and understand our motion toward them. In the far future, that knowledge may be lost as the expansion of the space pushes these landmarks out of our reach forever. We are the observers of a fleeting cosmic moment. So, the next time you look at that quiet, sparkling sky, remember that there is no such thing as stillness in space. You are currently on a planet that is spinning, orbiting a star, which is orbiting a galaxy, which is racing toward a hidden monster in the dark. You are traveling millions of miles a day toward a destination you can't see. The Great Attractor is out there, waiting in the shadows behind the Milky Way, pulling us closer to the heart of the Laniea Web. It is a place of absolute gravity, a graveyard of galaxies, and the ultimate architect of our corner of the universe. It is the most terrifying place we know, not because it wants to hurt us, but because it is so massive and so indifferent to our existence. It is the raw power of nature on a scale that humbles the soul. Thank you for adventuring into the zone of avoidance with us. The universe is a vast and scary place, but it is also endlessly fascinating. As long as there are mysteries like the Great Attractor, there will be humans with telescopes and equations trying to solve them. We may be small, and we may be moving toward the unknown at 14 million miles per hour, but we are doing it with our eyes open and our minds racing even faster than our galaxies. Keep looking up, keep asking questions, and never forget that the most terrifying things in the dark are often just the most beautiful things we haven't understood yet. The Great Attractor is getting closer, but so is our understanding of the cosmic dance. We are part of the web, part of the flow, and part of the mystery. And that is the most incredible place to be.